everyone. Let me first introduce myself to all of you. This is Ashnat Kothari here. I'm a teacher, actuarial science educator, and a minimalist. So in this particular video, we are going to discuss the solutions for CS2 A, which came in IFoA April 2022 session. Do note that these are the indicative solutions which we are coming out with. In case you observe any discrepancy, any calculation error, or any other errors, please let us know through the comment section. We would be taking a look at that, and in case we find merit in that, we would be uh, you know, uh, rectifying those as well. And please refer to the comment section as well. So all the viewers, whenever you are watching this video, just take a look at the comment section as well. We would be pinning our comment where we would be rectifying if any mistakes are there in this current set of video. So before we start with the discussion of this paper, let me just inform to all our viewers that we would be starting with offline classes in Calcutta, live online classes, as well as pre-recorded classes for IA July 2022, December 2022, and IFoA September 2022 session. The classes which are going to be held offline are exactly the ones which would be streamed online. So we have shared the schedule for major papers. We intend to conduct on average 4 to 5 classes every week. And this time we are again targeting to cover as many conceptual topics as we have. In the past 2 years, due to restriction of time and various other constraints, our live classes were primarily focused on doubt clearing. But from this session onwards, we are back to what we used to do pre-COVID. That is cover almost as many things as we can through live classes itself, be it offline mode or be it the online mode. Note that we just have a single batch, whether it's for the July term or for the September session or for the December session. So the classes which we are starting on May 8, 2022 is valid for all these three terms. We do not intend to start with any other new live batches for these. So in case you're looking to join us, do join us at the earliest. Coming to this paper CS2A, so again, students generally, among the initial papers, they do find CS2 to be a very challenging paper. Although at times it can be very interesting, while solving the questions. But just from examination point of view, most of the students find it challenging. In particular, I would say question 8, which was of Markov chain, specifically the part 2. I would say that in my personal understanding and as per my judgment, that was probably one of the most difficult questions I have seen in a very long time, specifically for CS2 or even earlier, let's say CT4 paper. So almost with all the students I had interacted with so far, none of them were able to, get that question in the examination, and not even beyond that. Only once, they watched the solution in the video I had released, were they able to make out sense, okay, this was the approach, else most of them weren't able to solve this. So it's perfectly fine in case you weren't able to solve it, because that really was a challenging question, and being able to solve that during the examination in a time bound manner would have been extremely difficult. As for the estimation of pass marks, a lot of you tend to ask me. So if you just ask me what's my opinion, again, it's just my personal opinion. The final marks would be released by IFoA and it could be very far off. But just keeping in mind the current difficulty of paper CS2A as well as B, and keeping in mind the historical pass marks, I think it should be 56 plus minus 2. That is my understanding. But again, this is just use this figure with a lot of disclaimer, or it's just my personal opinion, and the final marks could be way off different. Another thing, you would be finding the description, you would be finding the link in the description section for question 8 part 2. I wouldn't be covering that in this particular video. It is separately covered in a different video. So the link of that, as I already mentioned, would be available in the description section. So now let's get started. The first question is basically from modality projection. Part 1, part 2 are basically direct bookworks or commentary based questions. So we are skipping that because it's fairly straightforward. Next, question 2 is basically from exposed to risk. And here I have come up with a solution. Just do note one thing in mind. They have mentioned to clearly state all our assumptions. Now different candidates could come up with different assumptions, and the answer which I am coming up with, some of you would have a different answer depending on what sort of assumptions you have used. So again, if your assumptions are correct, if the examiner finds them relevant, you would be getting marks for it, even though your answer is different from what I have provided. So just keep in mind that there is not a single correct solution to this. It depends upon your assumptions as well. So I have basically assumed that PXT varies linearly, which is a standard assumption which all of you need to take. You cannot, it wouldn't really make sense if you think PXT to vary in some other way, because this is the standard assumption, standard methodology, which we have currently in our syllabus. Then I'm also assuming that data for PXT is available on 30th June 2016 and 30th June 2021. Some of you could also assume that data for these are not available, and then accordingly would have worked on. So when data for these two dates are not available, we basically need to use different set of dates. We'll see further when we need to calculate the value on 1st Jan 2017 and 1st Jan 2020. So two different set of values would be used for interpolation or extrapolation. Force of mortality is assumed to be constant between each x and x plus 1. Again, this is a standard assumption which needs to be taken. So do note in mind, I have made a timeline. Again, it's not expected you need to produce a timeline right now in the Word document. I have just drawn it so that it's clear how I'm going about with numbering. Again, different students could use different sort of numberings. So 1st Jan 2017 is 0 and 31st December 2019, or alternatively, one could have written as 1st Jan 2020 as time 3. So this is my preference. Whichever is the time interval of interest, I generally tend to put 0 as the starting of the time interval, and then I calculate the end of the time interval, and all the numberings are made accordingly. That is my preference. You all could have some other preference as well. Feel free to use any method which makes more sense to you. So my EXC will be integral PXT 0 to 3. Now, basically, I have data when at the points 0.5, 1.5, 2.5, and also I've already assumed that data for time minus 0.5 and 3.5 is also available. Had that not been the case, again, still the steps till this step, or I would say, let's say till this particular step had been the same. In fact, even till here, only finally when we had to replace px0 and px3, we would have used different set of values for whether you say interpolation, extrapolation. Ultimately, it's the same thing. More technically, interpolation is when we basically try to find the value of a function, knowing the value of the function at 2 points, and the particular point which we're looking at is in between that interval. Extrapolation is, let's say, you have the value of the function at two different points, and then you try to get the value of a point which is not between that interval. So the formula which we use remains the same, just technicality. For interpolation, the point is within the interval. Extrapolation is when the point is outside the particular interval. So this comes out to be px naught by 4 plus 3 by 4 px 1 by 2 plus px 3 by 2 plus 3 by 4 px 5 by 2 plus px 3 by 4. Now I basically use the formula of, let's say, interpolation or extrapolation to get the values of px0 and px3. And again, you could substitute this in the particular expression to get the final result. Next, question number 3. Now I would say this is a question, almost similar type, extremely similar, just leaving apart few numerical values. Apart from that, the entire structure, this has already previously been tested in a CT4 examination. So these kind of questions, what I suggest to students is ki even if you're not being able to solve it, you should be able to, because you have a reference point. Even if you're not clear with Markov jump concepts, so on, but something which has been previously tested, you should be in a position where you've prepared in a manner that at least ensures that a similar type of question can be answered, even in case you do not understand the complete logic of it. Just from exam point of view, while preparing, you should obviously target to have a very strong conceptual understanding, but focusing just on exam clearing point of view, this question should have been attempted and scored by almost all of you if you are preparing even at a very basic level, because a similar question had come in the past year. And I would be mentioning the year as well. So it was basically paper CT4, April 2013, and it was question 8 of the question paper. So this is the transition matrix. Part 2, I'm solving the differential equation. So you all could just take a look and tally the final answers. And in part 3, we are getting it in this way. This was question number 3. Again, I would say fairly straightforward. Then we have question number 4, which is basically on proportional hazards model. So first part is stating the term of the partial likelihood expression, and part 2 is commenting on the impact of two covariates. So I would be sharing the solution of part 1 shortly, and in part 2 all you need to do is, first of all, one coefficient is positive, one is negative. So you could say, whether they are having an increasing effect or a decreasing effect on the particular hazard. Secondly, you have been given the standard error. So you could come up with, let's say, a confidence interval, and then we could statistically say whether the covariate has a statistically significant impact on the particular hazard or not. So you will see that in first case, the interval for covariate x1 will not have 0 in it. It will just have positive values, means it is known to basically increase the particular hazard of interest in this question. Whereas covariate x2 will have the value 0 in its 95% confidence interval. By default, always take 95%. If you want to work with 99%, 90%, you could do as well. I am using 95% as reference. That would be having 0 basically, and so statistically we cannot say that the covariate x2 is significant. So this was basically commenting on part 2. On these lines you need to make a comment. Obviously it is of 5 marks, so it has to be a bit more detailed. I have just discussed in very brief. So this is question 4. The likelihood will be, the final result is this form: e to the power beta 1 plus beta 2 whole divided by 99 into e to the power beta 1 plus beta 2 plus 100 I've taken common, and then 5 terms. So note that there are 6 different type of individuals as per the question. And again, the first step would have been, you start with the hazard mu2 at time 3, and then in the denominator you take, let's say, all the 600 results. Note that it will be starting from life 2, because one life would have already been not in the data, because that person was getting away from the data at time 2 only due to the particular hazard of interest. So in denominator there is basically 599 terms. So this was question 4. Next, moving to question 5. It is based from Copula. Part 1 is commentary based question. So one of the things which you could mention is, the probability which the banking analyst is calculating as 1 by 200 is basically assuming that the probability of both the banks being insolvent is independent. But in reality, that isn't the case. Given that these two are large banks, they would have some sort of correlation. And if a particular bank is facing some issues due to which it is in a position of insolvency, there should be some positive correlation with other banks insolvency position as well. So we are actually underestimating the probability, since there should be, using let's say the practical understanding, what generally happens, the economic environment, that the probability should be actually higher than this. So to model that, we could use any Copula to model this. So that was basically for part 1. For part 2, we have 4 banks. Then there's a Clayton Copula as well. And we need to determine by first deriving a formula for the 4-dimensional Clayton Copula the probability that the all 4 banks will become insolvent in the next 12 months. Just to give you a reference, you would be finding a similar question in the material questions section only for Copula. There it has been given for, let's say, bivariate case only, but they have shown the derivation. So you could extend that for a situation where there are 4 covariates as well. So here, if we'll see, this comes to be the formula xi inverse. I put basically the different xi's. Then I basically also show the step, how I'm getting the inverse of the generator function, which is basically of the form t is equal to ax plus 1 to the power minus 1 by a. That is basically my inverse function for the generator. My inverse function for the generator is coming out to be in this form, and then substituting this over up and simplifying it, what I get is u1 to the power minus a plus u2 to the power minus a plus u3 to the power minus a plus u4 to the power minus a whole to the power minus 3 whole to the power minus 1 by a. A common mistake which I feel a lot of students could have potentially is, instead of writing minus 3, they could have written minus 1. Why would have that happened is when you're looking at the scenario of a bivariate case, in the material, you have a case where the generator function or the Copula function, sorry, is u to the power minus a plus v to the power minus a minus 1 whole to the power minus 1 by a. So you could just think, oh, okay, there are two cases. We have a u term, a v term, and a minus 1 term. So if there are four cases, we'll have four terms, let's say u, v, w, x, and again a minus 1. But that is not the case. That minus 1 was basically coming as, plus 1 minus 2, and here there are four terms, so it will be actually plus 1 minus 4, bringing it to minus 3. So this could be, what I feel a potential mistake which some of you would have made. Again, I would say a good mistake over here. Why I'm saying a good mistake is, at least you are trying to relate to what I've studied before, and trying to leverage the previous questions working. So in that way, it is good in the sense you must have definitely practiced a lot if you have come up with this error and you were in a position to make that observation, because a lot of students struggle to do that. And the probability value comes out to be 0.029756. Next, question 6. This is from machine learning. Let me share my screen with all of you for the solution of this. So this is basically the solution. You all could go through this for the machine learning part. This is part 1, part 2, part 3, and then finally we have part 4. Moving back. Question 7, I would say a very straightforward question coming from the topic, let's say risk models. So in part 1, we need to estimate the parameters of the Pareto distribution, and in part 2, we need to find the variance and the third central moment of S. Third central moment of S is nothing but basically, let's say, the skewness itself. And if we take a look at the solution, and it's working as well. So A is coming out to be 18 by 5 or 3.6. Lambda is coming out to be 26,000. Variance S is coming out to be 1.625 into 10 to the power 9. And skewness S is coming out to be, you all can just go through the steps and all, given that some of you might got have confused given we have a gamma 0.6 term, but you will see that ultimately it gets cancelled out. So it does not make much issue for us while calculating. And we're getting it to be 2.1125 into 10 to the power 14. Note that no rounding has been made over here as such. Then question number 8, again, part 1 is comments. Part 2 is something which as I mentioned, has been shared separately in a video. And just for part 3, keep very one important thing in mind. It is of 8 marks. Determine the stationary distribution of NT 8 marks. So you just cannot use R programming to get the answers. For cross-checking, you could do that, but you are expected to get the equations, right? You basically have 4 set of equations, with one of them being that pi 1 plus pi 0 plus pi 1 plus pi 2 is equal to 1, and then other 3 equations using the starting equation that pi t is equal to pi. You are expected to solve these, show all the relevant steps in a solution, because that will only fetch you 8 marks. Other than that, had it been of 2 marks, then you could have leveraged the R programming. You could have fed this transition matrix or whatever is the procedure there and got the final stationary distribution result. But if you have done that here, as per my understanding, you would be losing a significant portion of marks, because 8 marks, it means that you are expected to solve the different linear equations which you are getting over here. And this is the answer which I was getting. Again, I obviously myself didn't solve it using the set of linear equations. For the interest of time, directly used it from our programming itself. This was basically the stationary distribution probabilities. Finally, moving to the 9th question. Before that, I would just like to state that ones who read the question properly would have been able to attempt 8 part 3. Even if you couldn't do 8 part 2, which I feel probably almost all of you would have found it difficult to correctly, to get it completely correctly. Part 3 is just using data from part 2. It doesn't matter how part 2, data came. For part 3, you just need to use this, solve the various equation to get the answer. So this is where you need to keep in mind that you should be reading the question in completeness. One of the students was interacting with me and said that, after the exam later, she realized that she could have done part 3 because it did not require any information. You just had to use the data from part 2, and that is missing out of 8 marks. Given that, especially if somebody had time remaining, this was very much solvable. So always read the question completely. Even if you do not know certain parts, read the later parts. You never know, you might be in a position to solve the later parts even without solving the first few parts. Finally, question 9, this is from time series. Again, a lot of students found a lot of difficulty on this. Personally, I would say that given that it's an online mode of examination, it's on MS Word, so much of, let's say, mathematical steps or mathematical typing is something which has not been tested previously. And in this particular examination, I guess the tendency to ask such questions were a lot more higher. Had this been on paper, it would have been like any other question. But yeah, students were a bit surprised to see that in the overall paper, it was actually a lot of let's say to do with mathematical typing. But again, leaving apart that, I do understand that solving this question would have taken significant amount of time on MS Word. Nonetheless, this was very much solvable. Just that the structure of the question is a bit different. It hasn't been tested as such in the previous years, but the underlying logic remains fairly simple. So part one is derive in terms of B, the value of P that minimizes. So I want to minimize this. Now the first thing which should come to your mind is get an expression for xt minus P xt minus 1. You see xt is nothing but basically an MA1 process, if you will observe over here. So we know that the error terms, all of them are basically independent, and it's also mentioned over in the question as well. So you express all of these in terms of error terms, you square it. Since you know these terms are independent, when you'll be taking expectation, you can easily break them and work around. And then you need to differentiate it with respect to P so that this term gets minimized. So I would say this was doable. Again, typing it on MS Word could have taken a lot of time, but if you're doing it on paper, all of you should be in a position to solve this question. A lot of you simply saw the question, panicked, ki this is a very different question, never solved it, didn't even give it a try. Later only to realize ki how a simple this actually was. And when you'll be looking shortly at the solution, I guess a lot of you would be actually feeling that this was a doable question, not something which was very difficult or required you to apply a lot of your concepts. So I have defined xt, I have then defined xt minus P xt minus 1. Again, note that I always have a preference to give all the steps, because in case I make an error, it's very easy for me to go identify it and rectify it. Obviously, at times it takes, let's say, some more time, compared to if I'm skipping a lot of steps. But I would say that at least when I'm solving a paper, I will assume that I might be in a position where I'm making a lot of silly errors. So this is the way which in the overall scheme of things minimizes the time I need to waste in recorrecting things. And this works out to be an efficient way for me. And I think so this should be the case for most of you, unless you are very well prepared for a paper and you're getting things accurately correct almost every time, then maybe think of skipping steps. But otherwise, this is a more foolproof method. Then I square it. Now I basically take the expectation of it. Now, wherever there are terms of et minus 1, note that both of them are independent, so I can split it out. Again, noting that the expectation of et is nothing but 0. So this is coming out to be the answer, b by 1 plus b square. When b is 1, p basically comes out to be half. And part 3 is basically, again, getting this equation xt minus q xt minus 1 minus r xt minus 2. Squaring, taking, and going further, what I get is basically q as 2 by 3, r as minus 1 by 3. So I do hope that all of you did find this video very useful. We would be shortly releasing the solutions of the indicative solutions of CS2 B as well. So do subscribe to our channel so that you are updated with all the latest content we upload. Do like this video if you found it useful, and do share it among your other peers as well, so that they can take a look at these solutions and make an informed decision regarding which paper is to appear in the next session. Thank you.